Um, Here we have the last part of the lecture, which is the generation of the device and how the device work, how the ultrasound work. Ultrasound, first of all, the transducer, which is this one, his name is transducer. The transducer is produced and detected the ultrasound is produced and detected with the transducer, composed of one or more ceramic element with the electromechanical properties. Okay, so just like when the sound is coming here, it's coming as electrical signal from this power cable, electrical signal. When it's go there here, it will be transferred to be a mechanical signal, which is the ultrasound, and go there outside. How can we make this one? We have a ceramic element, which is transfer the electrical signal to be mechanical signal, and the mechanical signal to be electrical signal. The ceramic element will be convert the electrical energy into mechanical energy to produce the ultrasound, and the mechanical energy into the electrical energy for the ultrasound detection. Major components include piezoelectric material, matching layer, backing block, acoustic observer, insulating cover, sensor electrodes, and transducer housing. How many devices that we have? We have a different device, a different mode. We have A scan, we have M scan, we have two-dimensional B scan, and we have real-time B scan. The first one, the A scan mode, is the simplest type, and it always is one dimension. The A scan is just like when you are sending ultrasound to for example, the first block, the sound will be returned back to you. That means they will indicate that there is a sound, there is like a signal here. Then you are sending sound again, and it will be returned back to you. It will be like a sound and the signal, the second one. You go to the third one and return back to you. You will sign the third one. A signal transducer scan a line through the body with the echoes plotted on the screen as a function of the depth. Therapeutic ultrasound aimed at a specific tumor or calculus is a mode to allow for pinpoint accurate focus on the destructive wave energy. So just like if you want to know the location and the depth, you will use the A mode, and the A mode only for the one dimension. The second one is the B mode. In B mode ultrasound, a linear array of the ultrasonic simultaneously scan a plan through the body that can view as two-dimensional image on the screen. So here we have only one dimension. Here we have one dimension like a B mode, like a dots instead of the spikes, and we have two dimension as well. So as the image you see it in the hospitals, just like it's coming from the B mode one. Okay. The third one is the motion mode, and it's just like the motion mode is using like a to see how the things is moving. Okay, it's how the thing is moving. For example, the heart, how it's pumping, the valve, how it's opening and closing. And this one is coming from the same idea for the, let's say, for the taking the video for your mobile. You want to take it when you're recording video on the mobile. The idea is the mobile will be take images like in a short period of time. They will combine them together like animation. We will make it the imaging there, and it's important for the is used for the function is used for analyzing moving body parts, commonly in the cardiac and the fetal cardiac imaging. Okay, and this one we name it the M mode. Okay, what else we have? We have the Doppler ultrasound. The Doppler ultrasound is just like the idea of the Doppler ultrasound will be, let me define it first for you. A Doppler ultrasound is non-invasive test that can be used for investigate the movement and particularly evaluate the blood fluid in the arteries and the vein. It can be used for the heart valve defect, a blocked artery, and narrowing or stenosis of the artery. How it's working? Okay, we are all aware that the pitch of the ambulance siren changing as we stop and listen to it's a drive-by. So it's just like when you are standing like this and there is ambulance coming toward you, the frequency will be increased. When the ambulance is going far away from you, the frequency will be what? Will be decreased. This one we name it, this consequence we name is Doppler effect. And if you can see here, this car, let me do it again. When the sound wave is just like see again. So when it's near to you, you will see the velocity, the frequency is increased. When you're going far away from you, you will see the distances become what? become wider and wider, that means the velocity will be, the frequency will be decreased. So the idea is when it just like when the it is about the blood. When the blood going toward you, and this is the idea here is written here. When the blood coming, when you are sending ultrasound and the ultrasound return back to you, and the frequency of the reflected ultrasound is have high frequency, that means the blood moving toward you. When you are sending ultrasound and the ultrasound return back to you with the received frequency is less frequency, that means it will be the blood is going farther away from you. And how can we understand? We have something, we name it part. B-A-R-T. Okay. B is the blue. Okay. Blue, B blue. When you have a blue away, that means the blood will be moving away. Okay, so when you see any blue here, that means the blood is moving away from the transducer. What type of the frequency you will see? High frequency or low frequency? You will see low frequency. The R is the red one. And T, it means the blood moving toward you. So when you see the red one, that means you will see the blood is moving, have high frequency and moving toward you. This is how they recognize the blood moving from you, moving toward you, or farther away from you. Okay, and this is the end of our lecture. Thank you very much.